There you go. All right. Cindy, over to you.
Welcome. Welcome. Thank you all for joining us this evening for our webinar on heat pumps in houses of worship. It's good to see you. I'm Cindy Davidson, serving as Executive Director of Mass IPL. This evening, I'll share a brief overview of Mass IPL and why and how we make the case for heat pumps in your house of worship. We're pleased to welcome 3 presenters and latecomers. Our presenters this evening will each speak for about 10 minutes, sharing their experience, advice, and suggestions for your consideration. We plan on having about 20 minutes for questions and answers, and then we'll close out for the evening. We have many guests with us tonight, so if you are not familiar with Mass IPL, we are an independent nonprofit, one of 40-some affiliated state chapters of Interfaith Power and Light. We are bound together by our common concern for the care of creation as people of faith. We are funded largely by congregational memberships and shared collection plays, by honoraria from guest preaching and speaking appearances, and by individual donations, and we thank you for your support. Mass IPL helps communities and people of faith and conscience respond faithfully to the climate crisis and become better stewards of our environment. We do this across 3 dimensions: the spiritual, when we ground our responses to the climate crisis in the core tenets of our faith; the practical, when we take action to reduce energy consumption and carbon emissions; and the civic, when we advocate for sound climate and environmental justice policies and practices. We use the words pray, act, and mobilize as a tagline, and we organize our programming and activities in these areas. Let's begin by setting the context for today's webinar. We know that to achieve the state's goals, we must reduce the amount of energy we use through energy efficiency. We must produce electricity with solar panels. We must electrify everything and greenify, if that's the word, or build out and strengthen a wind and solar powered electric grid. We are fortunate that we have a state decarbonization roadmap. It calls for transitioning away from gas and oil furnaces and boilers to widespread deployment of heat pump-based electrified heating and hot water systems. Heating equipment typically has a useful life of 15 to 20 years, so unless you have replaced equipment in the last couple of years, you will likely be replacing equipment in your house of worship by 2030. So today we're taking a look at the leading technology, heat pumps. What's a heat pump? It's a pump that moves hot heat from one location to another, and you already have some heat pumps in your home. Because heat pumps are reversible, they can either heat or cool your space, depending on the season, and they move heat more efficiently than creating heat. As we hear from our presenters, keep in mind these important basics. You need to consider the pros and cons of air source versus ground source heat pumps in your context. Plan for ample time for a conversion to heat pumps. Do work with a mechanical engineer and keep abreast of mass save incentives. Some brief housekeeping rules. We're going to use the chat function tonight for sharing questions about the topic and directed to our specific speakers. Bill will be collecting them and then facilitating the Q&A. Later in the conversation, if you have a comment or experience that you want to add, please use the raise hand feature in reactions, which is found at the bottom of your screen. Try not to use the chat for conversations and greetings during the webinar. Okay, we are going to turn it over now to our first speaker. Let me stop screen share. Okay, first up is Matt.
All right, hello all. You just figure out how to share screens here.
There you go.
So hello, hopefully you're seeing my screen now. Get this out of the way. somehow. There we go. Hello, I am Matthew Bean. My company is Norian Ciani Engineering. We're an energy-based consulting engineering firm. We provide HVAC, plumbing, fire protection, and electrical design engineering. We've been doing this for a long time. We were founded in 1984, which means we've been doing this for almost 40 years. And we've been working with MIPL for much of that time. We started sometime around 2005. It's hard to remember exactly when, but we have a pretty long history of working with houses of worship and working with MIPL, which we've always really enjoyed and value our partnership. So I was going to talk a little bit about heat pumps and my thoughts and some of my expertise, and then we can go from there. So why are we talking about electrification? Buildings consume approximately 40% of all of the energy produced and generate about 40% of the carbon emissions. So that means to deal with our goals of reducing carbon, we have to deal with our buildings. And so I took this, built this graph to try to look at carbon's emissions for different types of heating systems that you often find in houses of worship, and try to understand the relationship of those. And so if you look at the bottom of this chart, oil-fired steam systems, many of the older houses of worship you're going to see have oil-fired steam systems. And the units of this chart are in pounds per million BTUs, but the numbers don't really matter. It's really about relationships here. And so an oil-fired steam system generates about 255 pounds of CO2 per million BTUs. If you were simply to change from oil-fired steam to gas-fired steam, which would be simply a boiler or burner change, you could save a significant amount of carbon. You could save almost 75 pounds per million BTUs. If you were to figure out how to burn the gas more efficiently, that would typically be through a condensing boiler with a high efficiency, low temperature hydronic system. You could further reduce the carbon because then you could burn the gas more efficiently, get more of the BTUs out of what you burned from the natural gas. Or you could convert to using electricity, which is a cleaner form of fuel. And as you see, an air source heat pump would use a fraction of what an oil-fired steam system would use to provide the same number of BTUs. So that's the big picture of why people are talking about air source heat pumps. Currently, I should say, this data is based on current New England, an average New England power source. Each town is different, but this is a pretty good estimation to first start thinking about how the emissions would change. It also is important to understand that one of the advantages that electrification has, and heat pumps specifically, is as the utility grid gets cleaner, as Cindy was just talking about, as the utility grid gets cleaner, if you're using electricity, then by definition, your heating system produces less emissions. I should say this is specifically about emissions. It isn't necessarily a given that changing from any of these heating systems to air source heat pumps is going to be some massive dollar savings in operating cost. So I want to be really clear. This is about emissions. This is not about saving you money. Now the hope is we can also save you money, but that isn't a given. And most of the time that we have run into people who are unhappy with choices about air source heat pumps, it's because they were led to believe there was a massive savings they were going to realize that they haven't seen. So what are heat pumps? How do they work? Well, Cindy showed you the prime example. We all know heat pumps. The refrigerator is a heat pump. We've all used them. It really is no different. And I'm not going to go into the technology of how it really works, but the thing to understand is a heat pump doesn't generate heat, but what it does is it's a system that moves heat from one location to another. And the beauty of the heat pump is that it can change that. In your refrigerator, you always move heat out of the refrigerator into the room. With a heat pump, you can go the other way as well through a simple changing of some valves within the system. So how have things changed? You know, heat pumps came to this area in the 70s, 80s, after the oil embargo and the energy crisis at that time period. And one of the real issues that they experienced were they didn't work very well at low temperatures. And many of the complaints were when it gets cold out, I can't heat my house, or it's blowing really low air temperatures. And that was really true. And they really got a bad name, rightfully so, but it really was an accurate representation of what was going on. Now, the technology's come a long way since the 70s and 80s. We now can run air source heat pumps down to negative 27 degrees, which is far colder than anything in at least the Massachusetts area sees. And you can get full 100% capacity down to -4 without a significant cost implication. And so that really means, first cost implication, I should say, installation cost implication. So that really means we can heat buildings with heat pumps with the newer technology. And that the fears that can we really heat the building really have been solved. So what are the primary types of heat pumps? So one that is probably the most common when you come to building systems are air-to-air heat pumps, air source heat pumps. They go by some varying different names, but really what it is you have an exterior heat pump unit, which is ground mounted, roof mounted, and then you have indoor fan coils, and you move heat between the outdoor unit and the indoor unit. A second kind of heat pump that is starting to become more common in this area, but is kind of at the edge of this process, but we're going to hear more about this over the next few years, is my anticipation, is an air-to-water heat pump. Now, this is similar to the air-to-air heat pump I just talked about, but the air-to-water heat pump has an outdoor unit that's very similar, except then you transfer the heat to hydronic water, and then you can distribute water like we have with baseboard and fan coils for years. The current technology maxes out at about 130 degrees. That being said, the indications are that those temperatures are going to go up over time. I had a manufacturer from Europe in my office the other day. They make a 160-degree supply water temperature heat pump in Europe, and they're trying to decide whether to bring that to the US, which really will be a solution for systems that are currently based on hydronic gas heating. Then there's groundwater source heat pumps. Now, groundwater source heat pumps are similar technology, except instead of using air at the outside, instead of having an exterior condensing unit, we use the ground. We heat exchange with the ground. The beauty of the ground is it's relatively warm. It's about 50 degrees in this area all year long once you get below the surface. And so you can, it's much more efficient to use the ground that's pretty much stays at 50 degrees than to try to take heat out of the air that might be down at 10 degrees, 9 degrees at design. And so where groundwater source heat pumps really come into their own is an efficiency. They are far more efficient than an air source heat pump is going to be. But they also are more expensive to install because you have to do the ground coupling, which is an expensive process. And so we often see building teams really want to pursue groundwater source heat pumps, but often budgetary constraints really bring you to doing air source heat pumps. So just so people can envision, sometimes picturing this equipment is helpful. This is kind of the equipment of a typical air source heat pump system. And what you'll see at the top is the outdoor heat pump. Those are, once you put them on a stand, those are 6 or 7 feet tall. Those are 5 feet long, 3 feet wide. So there's a large piece of equipment. They make noise, but basically that is fans and coils and where you can absorb or release heat depending on whether you're in heating or cooling mode. And then inside you have a variety of different types of indoor units that you can use. On the left is kind of a ducted system, which could be retrofit into, if you have current furnaces or other air moving equipment, you can retrofit something similar to that ducted system. The middle one in the picture I apologize for the picture, it didn't come out very well, but the middle one is kind of a wall hung plastic Heat pump, that's by far the least expensive option, but it has an aesthetic impact and so is only appropriate in certain locations. But that is a, for discussion purposes, call that 3 or 4 feet long, 18 inches high by 12 inches deep. It's usually mounted high on the wall in a room. And then the third one is kind of a recessed ceiling cassette that can be recessed into an acoustic tile ceiling in an office area. You often are putting those in individual offices, that kind of thing. So I share those, and there are a lot of other options out there, but I share those as kind of just thinking about how does this integrate into your building? Because, one of the critical things about working with houses of worship is the aesthetics matter. And so making sure we treat the houses of worship in a way that we honor their aesthetics is really important. So some parting thoughts and some things to think about, and Cindy said it before, but starting planning early. Where we've seen teams really struggle is, my heating system has failed. What do I do? And unfortunately, that's really late to start the process, because all of a sudden you've limited your options and some of these things take time. And so we encourage you, even if it's not going to happen right now, start the thinking, start contemplating how you might do this. So when you hit the point where you have failed heating systems, you're ready, how you want to address that. If you're going to electrify your building, you likely need an electrical service upgrade. The vast majority of your buildings will. And that is important because, one, it's really expensive. And two, at least right now, supply chain and equipment issues are causing major issues. It could be a year before you can see the electrical equipment you need to put into your building. So if you ordered it tomorrow, you might not have the equipment for a year, and you need that before you can even start to think about heat pumps. And so understanding that and thinking about that early is important, because again, like I said in number one, once your system's failed, if you call me today and say my system's failed, you may not be able to electrify the house of worship before next heating system. It may just not be possible, regardless of if I can help you figure out how to do it. You just may not be able to get the equipment to achieve it. So phase construction, doing a little bit of your building, and this is something that I know that we've worked on with many communities, and is often something worth thinking about is, if you imagine a building that has a sanctuary that's driven by an oil-fired or gas-fired steam system, but then has an office area that is also currently on that system. You can think about, well, let's electrify the office area that's used much more than the sanctuary in hours a year. And that allows you to start to step into this. It allows you to start to learn about electrification and allows you to maybe limit some budgets. You need to be careful with the phase construction, because if you peel off too much of a system from the existing system, you can negatively impact the system that way. And so, if you want to take 50% of the system off an existing steam system, then you're going to cause problems to the existing system that may cause so much energy waste that it may not be worth considering. So there is some limits to that, but it is something you can consider. And then if you do nothing else, at least as if you think about putting in hydronic systems, make sure the designers are not designing with an idea that there'll be supply water temperature over 160 degrees. This is at least set yourself up for the future. If you're going to have to work on a hydronic system, modify a hydronic system, improve a hydronic system, tell your designers to design around 160, so that when this future technology comes, you're able to retrofit at that point in time. So I can talk forever about this stuff, but I think that's about my 10 minutes. So I'm going to stop here and I'm going to turn it over to Susan. And as soon as I can figure out how to stop sharing, there we go. So thank you very much for listening to me.
Thank you, Matt. Susan.
Okay, I'm unmuted and I'm going to try to share my screen. Let's see if we can make this work.
Excellent.
Good. Okay, hang on. All right. Okay. My name's Susan Adams and I'm head of the stewards at the West Concord Union Church. Stewards is our name for what many UCC churches call trustees. I am not head of this project by any means. So the head of this project is in Sweden presenting on something else tonight. So you've got me. I'm using slides that we used at various congregational meetings to help us figure out how this went. Impetus for our project was an old oil-fired steam heat boiler, just like everybody's been talking about. It was costing us a fortune to maintain. We had a lot of trouble finding a company who could repair the boiler well. We had fluctuating oil prices, and we had also over many years of kicking the can down the road on this problem. We had done renovations where we'd added old, what are now old air source heat pumps that were supplemented then by our steam boiler, just the way Matt was talking. So we also had some electric heaters, just resistance heaters, because we'd also divided our space into parts of our space into small rooms to accommodate our primary tenant, who is a nonprofit music school. So they needed small teaching rooms. But the combination of the old air source heat pumps and the steam heat for the colder weather, and not enough little rooms with not enough controls, not enough thermostats, the music school folks were unhappy. It seemed as if we were always too hot or too cold. And we decided to finally face the problem, and we organized an HVAC task force in 2021. And we began working with Norian Ciani Engineering to figure out our options. We had done a fair amount of benchmarking before we started to work with Norian Ciani, and I can't recommend that enough. Get benchmarking. Know what you're spending. Know what's happening now. These are the options that the task force came up with. We have no gas currently in our building. So, but we could have, at least theoretically, brought in a gas line. I'm sure that somebody in the town would have objected, but we could have brought in a gas line and done forced hot water heating using gas. Or we looked at air source heat pumps, and we looked at ground source heat pumps. While we appreciated very much the ground source heat pump notion, we don't have enough real estate to be sure that we could use, that we would be successful, even if we made this choice, which was a very, very expensive choice. And in the end, we recommended air source heat pumps. So in March of 2022, we brought that idea. That's when we voted to do this, and the congregation then decided to put $250,000 towards the building envelope work and engineering design work. And we began doing those things. We had hoped to do all of the work. We had a notion, just like Matt was saying, oh, well, we'll do it over this next summer, but there was no way that was going to happen. And that became clear eventually. Whoops, what did I just do? Let's see. These are our costs to date as of, I guess, March 2022. Then some of our design features that we have done is we've continued, well, we upgraded our electrical service, and we made a choice in upgrade where we are going to upgrade our electrical service. We made a choice to upgrade more than we would actually need for our heating system so that we could in the future put in an EV charging station. We're trying to look ahead to think about what we might want to do in the next project and not miss a chance to do good work. Oh, back to that slide, sorry. We also made a choice to continue to use some of the fan coil and sort of radiator stuff that's in the sanctuary that's left over from our old heating system in order to preserve the aesthetic of the sanctuary. We have beautiful woodwork in our sanctuary, and we made a choice that was probably cost us something like $40,000 to continue to use some of that way of spreading the heat. It's still the water that will flow through some of those fan coils is still heated by air source heat pumps, but it's hydronic baseboard heating actually, and that was an aesthetic choice. Let's see what else. I think that's the important stuff here. This is the kind of diagram that you'll get from an engineering firm. This shows where our ducted hot air will be, ductless hot air. Another reason that we chose to do an unusual thing in the sanctuary is to have the heat come in at a lower level than some of the heat pumps would have allowed us to do, where the people are sitting as opposed to a little bit higher up in the building. Okay, this is an electrical design. And our construction cost estimates. We finished all of the design work in December of 2022, and we went out for bid. And I'll just tell you that we were very nervous because also our friends at Nori Anciani were very nervous that no one would bid. Who would bid on this? And we were quite worried. We ended up getting 3 bids. And you can see the range at the bottom here, pretty big range. We had 2 bids that were very close around this 1.28 and 1 bid that was quite different. And ironically, the bid that was much higher came from a company that we had experience with and that we had sort of been hoping, oh, maybe we can work with them since we know them and we trust them. But their bid was way high. The other 2 are wonderful firms. One a little larger than the other. One was kind of a one-man band plus workers that he hired. The other has multiple projects going at once. And we ended up going with the larger firm, sort of thinking of COVID and what happens when one person gets sick, like the lead person, and suddenly you have no one to protect, to continue on. I think that influenced us a lot. So here's the remaining project costs. There's our construction costs. We've hired a project manager, someone we've worked with before. There's finish work that still needs to be done. We're hoping to we believe we will get rebates through Concord Municipal Light and Power. And we've put in a 10% contingency. Let's see, a little more information. There's the upgraded electrical service, I think is one of the most interesting things that we're hoping to be able to do an EV charger in the long run. We've ordered equipment, had to order equipment, and we're just praying that it all comes in as quickly as we think it will. Here's our our timeline, and you'll notice, let's see, we had hoped to begin construction work about 2 weeks ago, and what held us up was the closing on our construction loan. We're working with Cornerstone, and they've been great, but I think anybody who's trying to get a mortgage these days knows that it's not as straightforward as maybe it used to be. But we have now closed on the loan, and demolition work will begin on Tuesday after Memorial Day. Our biggest project challenge is cost. We have had a big campaign that I could talk about, but I won't right now, about how you raise money. We applied for multiple grants. We did not get any of them, and we may still manage to apply. In some ways, I don't know if everybody else in this Zoom got today something about the Department of Energy's, well, let's see, the grants that are available through them, through the Inflation Reduction Act. And they're pushing very much, you may all have been to a webinar about that the way I was. They're pushing very much groups of buildings working together. And we are a little bit ahead of the timeline there. We can't not do our project in order to wait to join a group. So that's sort of been a disappointment, but anyway. So that's my last slide. We're proceeding with Fraser Engineering, and we hope to get done by the heating season, beginning of this heating season. That's next, when does it start? October, November. Okay, I'll stop my share now.
Thank you so much, Susan.
You're welcome.
Okay, let's turn to our third presenter, Mark.
Okay, can you see my first slide?
Yes, yes.
Okay. So, yeah, my name is Mark Morgan. I'll make this bigger if I can. Okay. Yes, I'm a member of Faith Lutheran Church in Andover. It's an ELCA church, if that's of interest. You can see a picture of the church. It's a little bit bigger than that, but notable. It's a newer church, 1970s vintage. One floor is where most of the, almost everything is existing. Current church is about 6,000. So I just give me a little bit more background about myself, actually. I'm a member of Faith Lutheran Church. I also work with the sustainability group in Andover called Andover Weekend. And I also work with the Heat Smart Alliance, which is a group that provides coaching for residential heat pump issues. I came into this project after we had installed the heat pumps. We were using the heat pumps, and actually I got really involved during the coronavirus, which I'll tell you a little bit about. So my talk is mostly about operation. It's not about design. It's not about construction. It's just like, what is our experience during the operation of the system? So current church is about 6,000 square feet with a 2,400 square foot sanctuary with a vaulted ceiling. Originally, it was all electric heat baseboard with no air conditioning. So like a 1970s vintage. In fact, this is a really good system to think about replacing heat pumps from the operating cost. As Matt said earlier, sometimes the operating cost isn't so much better, but since the coefficient performance, the number of BTUs you get out per BTU in of electric baseboard is close to 1. But with the heat pumps, it can be 2 or 3 or even higher. So you can cut your energy use quite a bit, and you're always paying for electricity. We added heat pumps in 2 different phases, and is common in residential. The first edition was in a new construction. They actually both happened in new construction. So we added some classrooms to the facility in 2012, and we added heat pumps as the heating source for that. And then we renovated the sanctuary in 2019, and we added heat pumps as the source there. Baseboard electrical remains in the other facility areas. I wasn't on the decision, but mainly I think because maybe Matt said or somebody, we're just doing it in steps, and it seemed like we were already spending enough money in 2012 and 2019, so maybe in the future we could do the other work. Currently, the congregation, so we've dropped a bit, as probably just about everybody has. We're at about 350 active members at the moment. Sanctuary has 3 external Fujitsu units and 5 internal heads. So Matt showed you the big units, I think he said 5 foot or something, 4 to 5 foot outside. And inside we have 5 heads. So 2 of the units have 2 internal heads. It's a mini split system, not ducted. Classrooms have 3 external Fujitsu units with 3 internal heads. So they just have 1 head per unit. The sanctuary, 2,400 square feet, has a total capacity of 7.8 tons. And the heating capacity is the same for this particular type of Fujitsu heat pump. It's the same at 47 degrees F and at 5 degrees F. So it's pretty good for cold weather. Classrooms have total capacity of 4.5 tons. So it's pretty much 1.5 ton per room. If you're looking at a home with a 2,400 square footprint, 1 floor, you would likely get significantly less than 7.8 tons. But I think the reason for the design, I wasn't there for it, is the vaulted ceilings. It's a big volume. It's not just a square footage, but it's the volume that's important for this situation. So here's some pictures. On the right, I don't know if you can see my cursor, but on the right is the sanctuary. Looks kind of familiar to people. And the heat pumps, I'm going to show you, they're along the side of the sanctuary above the windows. Okay. So over here on this lower left-hand corner, you can see them. As Matt described, these are called wall units. We have 5 of them. They're located all on top of the windows. They're pretty unobtrusive. Maybe getting used to is that instead of using the electric baseboard, which has a certain feel to it, the heat pumps are blowing air. So, there's different controls on how you blow the air in terms of what direction and everything, which took some adjusting, because even if you have 70-degree air, if you blow it on top of somebody, it makes them feel cooler just from the, whatever it's, what do we call it? Wind chill factor, let's say, because your body is warmer than the air. And here is the classrooms. These are typical classrooms. You see this thing where we can divide the classrooms into 3, or we can open it up into 1, these movable walls. And we have these 3 heat pumps here. So just a little bit about the coronavirus. The coronavirus, that's when I was the head of the group to determine what to do about the coronavirus. And we focused very quickly on air quality. It's the one thing that we could control in the church. So we tried to reevaluate the air quality. What could we do? We actually got an engineering study on that to see like the different methods for improving indoor air quality. And we were looking at different systems, and we tried different solutions. See a misspelling there. Air exchange rate. So how often air is coming into your building versus like the volume of the building. So there's a certain rate of that you need to keep safe. And there was standards that were set during coronavirus. Air cleaners were looked at. UV virus destruction, which is something that sounds a little bit strange, but actually it came into play as one of our main solutions. Mask, limiting the time and limiting the number of people in the services. We kind of played around with all of those. In the end, we tried all the ideas, but we do have some lasting solutions. You can get, if you have a current heat pump system with an internal head, and in fact, you can do this with a ducted solution too. You can implement UV strips. So they're very small strips, maybe 1 inch by, I don't know, up to 6 or 10 inches, that have little UV lights on them. These lights are particularly UVB, and they kill viruses and bacteria that go past them. So they're pretty effective. This UV light is used in medical facilities now. It's becoming a little bit more. Doctors and dentists had it during coronavirus. Most of their air cleaners had UV stuff, and so there's different ways of implementing it. But we were able to implement a heat pump, and we got new ceiling fans. So one of the things with our system, you're blowing air. The ceiling fans are pretty effective in distributing the air so that to reduce the amount of difference in temperature from one point in the room to the other. So it's a way of mixing the air. But this particular kind of UV fan is sold by BAF, and they are big fans that you can see even in shopping malls and stuff like that. But anyway, they have a UV light on the top of the fan, and that's pretty effective at irradiating the stuff that goes by. So we implemented that, and I mean, there's no like direct evidence on it, but we really haven't had any problems. We actually had one problem, but they weren't using the fans at the time, or the heat pump. So I don't know if that was the reason, but we really made it through in a pretty good way. So in terms of heat pump operation, what are we thinking about? I listed down 4 big things: comfort, safety, cost, and ownership. So go down through comfort. You know, if you work in a church and you work in heating systems and stuff like that, it's impossible to please everybody. I mean, somebody's going to be too cold, somebody's going to be too hot, somebody's going to say that where their seat is in the is in a bad place for the heating system. You have to try to work through that in the best you can, of course, with respect to everybody. But the key for us for the system was to minimize the temperature distribution in the sanctuary, top to bottom, side to side. So we had to look at where are the fans from the heat pumps blowing, where are the ceiling fans operating, and how, and when. And also the issue is, like we talked about or was mentioned, how do you apply the heat? Do you turn it on 24/7? Do you turn it on just for the services? Like what's the solution to that? Because if you only turn it on for just the services, you're going to have a cold room that's never going to really heat up. And so you're going to have more temperature distributions, whether it's blowing from the ceiling fans or whatever. It's going to be, but on the other hand, if you heat the sanctuary 24/7 and you only use it for 3 hours a week or something, then there's a question about how effective that is too, right? So safety, I talked about safety with the coronavirus in particular. Cost, so we need a evaluation. So we don't actually have a final understanding of the cost. A number of reasons for that. The coronavirus changed things a lot. In a church, we're a small church, so we have volunteer people who are in charge of the facility. So it changes all the time. The philosophy about operating the heating system changes all the time. So we have numbers, but I'm not really sure what we can take out of it. On the other hand, we asked the IPL guys to do a audit of our church. They're in the process of finishing that and giving us some good ideas about how we can improve things and where we are, and in relationship to other places of worship. As I said, I work with residents, but I don't really work with churches, and I think that there's a pretty big difference. And ownership, and I mentioned this during our talks a couple of times, but basically there's a critical issue in the congregation. So we had to quickly move away from everybody turning up the heat when they felt like or turning it down, and it's just a crazy scenario that everybody kind of like deals with, and just try to remove that possibility and have a strategy and keep with it. So those are like learnings that we had in terms of operation. So key aspects. So determine who can operate the controls. We have like 2 people that really are in control. In the winter, so the thing is, like in the winter, we use our sanctuary pretty much every day for a couple of hours. So that gave us a dilemma. We really needed to keep it somewhat heated during the week. And you also don't want to let it go to freezing or anything. So we set our controls down to 60 degrees F during the week. Saturday evenings increase to 72 and decrease it to 60. And use the fans to distribute the heat. That's been working pretty well. And again, we haven't really evaluated the cost. I mean, when we first started, it was all about safety. And then we had to figure out how to make it comfortable. And now I guess we're going to talk about cost a little bit more as we go forward. In the summer, we just turned it on to 72 on Sunday morning. What I found with the heat pumps, at least in my house, and I think the cooling system works really quickly and well. I mean, the heating system works great, but it takes a little bit more time to get everything together. I think it's just because the temperature difference, when the outside is 10 degrees or even 30 degrees, and you're trying to get up to 70, it's different if the outside is 80 or 90, you're trying to get down to 70. And you get a big kick
Mark,
dryness.
This is Bill Schroeder
Yep.
chiming in. I'm wondering, we've got a lot of questions that people
Okay,
have
okay.
asked, and I'd like to try to get to those. If you can sort of wrap it up, please.
Wrap it up. Okay, I thought I was gonna do good with that, but I'm sorry. In conclusion, we're happy with the heat pump systems in terms of air comfort and air quality. It took work to understand how to control them and patience for our congregation as we learned, and they can be used to improve air quality. And we're now trying to look at how we can improve the energy costs and use. So, sorry about that, Bill. I was trying to keep time.
Okay,
Thank you.
thank you. So at this point, I'd like to move to the questions. We've gotten a lot, and I imagine we'll have more as they come in. And I'd like to take them more or less in the order that they came. So the first one is a person commented that houses of worship are used a lot on Sundays, or your worship day if it's not a Sunday. And wondering, does the uneven daily use cause a problem for ground source heat pumps or maybe air source heat pumps? And I think that might be a question that would be good for Matt.
So the short answer is no. The groundwater source heat pumps are really about yearly, making sure that you're taking out of and putting back into the wells an equal amount over the course of a year. But all of these systems can do okay as far as only being used for a day or two a week and then being very marginally used the rest of the time. There are some design considerations to think about in sizing of equipment and choosing equipment, but generally, no, that shouldn't be a problem.
Thank you. We had another question, actually a couple of questions having to do with getting money, rebates, and incentives from either state or federal government grants. And Jim, I think you have a lot of knowledge on that. Are you available to answer a question on that?
Sure. Sure, yeah, I guess. Obviously, the most immediate program to tap into is the Mass Save program, which gets a little challenging to navigate for houses of worship because we're a type of building that doesn't neatly fit into the boxes that the Mass Save program has. But generally, it goes by your rate class that you're billed at, whether you're residential or commercial. And the weird thing is you can have the exact same piece of equipment. If you're billed at a residential rate, you get $1,250 per ton. If you're billed at a commercial rate, you can get, I think it's $3,500 per ton. And Matt may even know more than I do about that.
Actually, Jim, I
so it
think
takes
it's
a little bit to-
$2,500 if it's a regular heat pump and more if it's a VRF heat pump.
That could be, yeah, it gets pretty complicated. So you just need to make sure that you're in touch with Mass Save. You may need a Mass Save assessment in order to qualify for anything. And then make sure that your contractor is very familiar with the program, because oftentimes they will handle sort of the paperwork and things with that. And I know our old friend Susan Evans is also very knowledgeable about Mass Save as well. So if I've said anything wrong, Susan, jump in and correct me.
We had an interesting question and comment from Paul Gentili. He said they were not able to get rebates due to low building use. And I'm wondering, were you talking, Paul, specifically about Mass Save rebates that you couldn't get, or what?
Yeah, yes, we had the interface power and light audit. We had the Mass Save audit also. And they came in, and because of the building we're talking about would be a building that is 1/3 used for offices during the week, and 2/3 we were going to be using for special events. It's our hall. They said that because of the the low operating hours of the hall portion of the building, we could get hardly any rebates at all. And we were willing to go the extra mile to have this installed, and it really diffused a lot of activity on our part.
Interesting. That's the first time I've heard of that kind of a thing being applied to this heat pump rebate. Does anybody else have any experience with that or comment on that? It's a new one on me.
At Faith Lutheran, we got rebates for our project.
Okay.
I don't know the numbers.
What were the operating hours?
Yeah, I don't know what the application said. I mean, we're just a church. I mean, there are people there during the week. You know, there's offices and things like that, but I don't know
Oh,
how the application worked.
Yeah, how recently was this, Paul?
2020.
Okay.
I'd like to
That-
have someone contact me. Originally, Tom Nutt did the
Yeah,
study for us.
Yep.
And I'd like to have he or someone else contact us, because I know we're still interested in the effort. We just
Mhm.
can't seem to get by that rebate issue.
yeah. Paul, I'll reach out to you and see if we can figure
I'm
out
in St.
something.
Barnabas in Falmouth.
Great. I'll be in touch.
Okay.
Okay, the only other thing I would say on this particular topic is that the Mass Save program changes every 3 years. And I think it was in 2021 that the new program began, which had much larger incentives for heat pumps. So that's good for 22, 23, and 24. So it may have been different rules if it was before that time. And we certainly want to look into that because obviously an awful lot of our faith groups would like to heat the sanctuary, and the sanctuary is only used once a week. So that becomes an issue of a lot of important stuff. So there was another question about, can we get PowerPoint slides from these presentations? And I would think that the answer is we will work on that and try to make them available. It depends. We'll have to get back to the speakers. We didn't ask them whether they were willing to provide them for, but there will be a recording, so you can look at them that way, if no other. Someone was asking, what are good sources for grants? And Susan, I wonder, you looked into that and are probably still looking into it. Do you have any comments or suggestions on that? And then I'll ask if anybody else, amongst the panelists have some comments on grants also.
Well, you might look into what your own town offers first, although Concord's, I'm trying to think, Historic Preservation Act only goes for, does not apply to churches. But in other towns, I think it has, those funds have been available to churches. We also applied to, I hope I'm going to get this right, the Fund for Historic Spaces. I'm not getting this one right. And
Sacred Spaces?
Sacred
Does that sound
Spaces.
familiar?
Yes, Sacred Spaces. And we applied for one of those grants. And we did not make the first cut. But if you can make it through the long process, there's significant funds there. And then we applied for a small grant through Interfaith Power and Light, I think. And we did not get that either. But our timing is off for the big government grants. And I keep waiting also for direct pay to be announced through the Inflation Reduction Act. But that hasn't been announced yet, so far as I know. Those are the places that we have found.
Okay, good.
And your denomination may be able, whatever denomination you are, they may be able to help you find other places that have grants.
And
Yeah,
if
that's
not
an especially good
grants,
point. Jim, did you have some comment on that?
I was going to say, and if not outright grants, many denominations have low-cost loans.
Yes.
And I know there are a couple of denominations have an even lower interest rate if it's something for climate change and carbon reduction. So definitely check with those sorts of sources from your own denomination.
I noticed that there was a question about what about the Mass Save program if you're in a municipal light town? And I think the answer to that is you probably don't qualify for Mass Save. So you'd have to talk with your municipal light company and see what kind of benefit they would be willing to give you. It is possible, though, that if you get gas, for your heat now, from a Mass Save company in a municipal light town, you might be able to get the gas company, if they participate in the Mass Save program, to provide you some incentives for a conversion. May sound crazy that you're getting rid of gas and going with electric heat pumps, but they actually get credit for reducing the amount of gas consumption through the program. So that's a possibility for you if you're in a muni-like town. Someone asked a question about, can a heat pump provide cooling for an existing forced hot air system? And that sounds like an engineering question. Might ask Matt Bean about that.
Yes.
The short answer is yes. You can. There are lots of different pieces of equipment out there, and depending on what you have going on, you can certainly figure out how to put cooling into an existing system. The real question is the ductwork you're feeding insulated, or where is it located? Because the problem with heating only duct systems, if you add air conditioning, there's the risk of condensation on the exterior of the ductwork, causing mold, dampness, all sorts of things none of us want to talk about. And so you just have, yes, you can do it, but you have to be conscious about what existing systems you're connecting to, and are they appropriate to run air conditioning in. And there
Okay.
are some tricks to get around that, but that is a concern when you start dealing with existing systems.
Okay. There was a question, someone asked specifically of Mark about in the sanctuary, do you have a high ceiling, and is that an issue with respect to distributing the heat? And I noticed he gave an answer to that because it happens they have fans, and in fact, large fans in their sanctuary, and he said that they help a lot with the distribution of the heat. But I'm
Yep.
thinking more generally, what's the situation? And again, Matt, maybe you could comment on it. If you are trying to do air source heat pumps, air to air in a sanctuary with a tall ceiling, what issues do you have to try to heat it right?
Well, stratification is one of the big ones. The heat wants to rise in a tall space. If you blow warm air into the space, the heat tends to rise. And so, as Mark described, destratification fans is one approach. Also, making sure you're providing the heat low down helps improve the function of the comfort of the heating system. And that can be done with floor grills. It can be done, it depends what's going on below the sanctuary. It can be done with air to water heat pumps. And so then you can talk about perimeter radiation. So there are ways to try to make it more comfortable. And the other one, the one that jumped out at me, Mark, what you were talking about, you turn on the sanctuary on Saturday night. So presumably what I heard there was, so it was comfortable by Sunday morning. Warming up the sanctuary a little bit ahead of time so that you're not 50-degree walls and then just, yes, you can make the air 70 degrees, but if you're sitting in a room where all the walls are 50 degrees, it doesn't matter if the air is 80 degrees, you're going to be cold. And so there's some operational ways to address that.
Thank you. Another question we had was directed for Susan. What percentage of your project cost was the weatherization that you did beforehand? Approximately, roughly.
Right. It was not a large amount of our cost because in our prior renovations, we had done some window replacement already. So we did do 17 window replacements at a price of about $32,000, I believe. And we did some insulation, once again, because we had there some insulation in the walls of the sanctuary. We missed a chance quite a few years ago, the last time we did our roof, to insulate. So if you're thinking about doing roofs, look at insulating your roof because that's so crucial. It's something that we have to wait on. So it was much less than we thought it would be. I think we appropriated up to something like $200,000 for that building envelope work, and we did not spend that much. We have huge stained glass windows in the sanctuary, and we talked to some people about kinds of storm windows on those and chose not to do that. I hope that answers your question.
Okay, thank you. I noticed that some more questions have come in. One is, has anyone looked into PACE loans through Mass Development? They fund long-term loans for commercial buildings. Anyone have any comment on PACE loans? Looks like not.
I'll just say, my understanding is that first of all, your town has to sign up to participate in PACE. PACE is Property Assessed Clean Energy. So it's typically, when we talk commercial buildings, we're talking more typically kind of big office buildings, even retail, malls, things like that. And what happens is the loan is actually serviced through your town's property tax assessor, and it is added to your tax bill, even though it's a loan repayment, doesn't really affect your tax rate. But you get the advantage of the municipality typically has a lower borrowing interest rate than other entities would have. And it's great for other types of commercial buildings where if you sell the building or sell the property, then that loan stays with the building, not something that typically we would be dealing with very much. So anyway, first of all, your town has to have decided to participate in this. So you might check with your town to see if your town does that and then go from there.
Okay, we have a question that probably would be one for Matt. It says, to have enough money to convert to heat pumps, our congregation will need to run a capital campaign. To run a campaign, we need to set a fundraising goal. How much money do we need to get this done? And we need a rough idea of what the new system would be like. One congregation we heard from showed a large portion of the cost was for design and engineering. How much might we need to spend to get enough design done to know what it's going to cost? Matt,
That's a very common question.
That's a challenging question. I mean, the answer is, it depends, of course, which is a useless answer, but is the truth. I would need a little more information about the building, and we could start some back of the envelope rough estimates to understand, big picture and cost to do it, and then what does it cost to engineer to start to refine that. So I would say you reach out to somebody, myself or somebody else, and you ask them to help you with some more specifics about your building. Then we can start to help narrow that down. But it's hard to just throw a number out there because there's too many variables.
Right, but it might be an iterative process where you could take a look at the building and give approximate numbers and then refine it more as you do a more detailed analysis, something like that.
Yeah, that would be my anticipation. I mean, we could have a conversation and start to understand, start to get ballpark numbers, and then we can see where to go from there, is how I would typically approach something like that.
Okay, and while we've got you, the next one looks like it might be for you also. Our sanctuary has in-floor hydronic heat and air conditioning through ducts. Is it plausible to convert that to heat pumps?
Yeah, you're super lucky. That's a great system to convert to heat pumps, because you can do, likely an in-floor heating systems running at very low water temperatures. The air to water heat pumps are the exact type of equipment for that kind of heating system. And then as far as cooling, you would do a coil that would allow you to provide air conditioning to the ducted portion of the system. So that kind of system likely would be a relatively easy type of system to convert.
Thank you.
Thank you.
Oh, here's a good one. How do we get on a notification list for news related to the unfolding of the IRA's provisions?
Yeah, I had actually replied directly to Lori on that one. There's a site
Oh,
called
okay.
Rewiring America, rewiringamerica.org, and they were very involved in writing the IRA, as I understand it. So they're a really good source. There is also a government site, climateprogramportal.org, which is a very comprehensive listing of all sorts of different monies, most of which are not relevant to us. So you kind of have to do some digging through it. And quite frankly, I don't have the patience to do a lot of that. So it's a little bit daunting, but for those of you who do, you might find that. And I'm also searching. I know back in the fall, the White House had launched a page for a lot of this stuff, and I'm doing a little searching to see if I can come up with that. And if I do, I will pop that in the chat or jump back in and say, Eureka, I found it.
Okay, well, while you're doing the research, I'll move on to another question. Loie Hayes asks, has anyone had experience using the new heat pump program at Energy Sage? I noticed that they do have a commercial option. I didn't know Energy Sage had a heat pump program. Anybody experienced with it? Sounds like it's too new. I'm not seeing any hands waving.
Has anyone here used Energy Sage for solar? They've been a partner of ours for a number of years, and we always recommend that as a possible source, but I don't know that a lot of people have actually used that versus the other solar partners that we also recommend. Is what the benefit of it is they have a pool of contractors who subscribe to this service, and basically you go on, you set up a free account, you put in some information about your project. In the solar side, it's what your electric bill is, and some other information like that. And then, those solar installers will take a look at it, and if it's a job they're interested in, they will be in touch. I assume it's going to be a similar sort of structure for the heat pump thing as well. But presumably it's a relatively easy way to get in touch with and hear from a number of qualified contractors.
Jim, I noticed that Lori Kenshaft had raised her hand and had a question or something, and I think you may need to unmute her.
Oh, okay. We'll find
Lori Kenshaft.
I think, Lori, you should be able to unmute yourself there. Oh,
I
hi.
was simply responding to the question about whether anybody has used Energy Sage for
Mhm.
solar, and I have. I am a trained heat pump coach for Electrify Arlington, and so most
Ah.
of what I do is help people with residential heat pump installations. When people have questions about solar panels, I talk with them a little bit, and then I send them on to Energy Sage. So that is Electrify Arlington's approach, and so that's my experience with them. And I also use them in my own home.
Thank you. Thanks very much.
Thanks for updating me, and I'll let you know if I learn any more.
And Pam has a hand up.
I want to mention something, which is that if you can use solar, you install solar, let's say on a roof or something like that, that can run your heat pump, and the cost
Absolutely.
of electricity is eliminated if you get a suitable solar system. Because I have that on my roof. I have 24 solar collectors and a heat pump, and my heating and cooling bill is $450 a year. So, you know, and also PACE. I am familiar with PACE. We passed it in our town just by a vote of the selectmen. It was very simple to pass. And PACE is specially designed not to make you comfortable and happy in your church, but to lower the emissions for climate change. And that's a major position for many of us, is a moral and ethical dilemma. And so PACE, we had the first PACE building in the state, in my town, which is Greenfield. And churches are commercial property, but I think you're right that it may depend on how much the church is used during the week in order to be eligible for a PACE loan. PACE loans are very long-term, like 20-year long-term loans for commercial property, and very low cost. And it's worth looking into through mass development. I think, you know, if a number of churches could develop the kind of relationship with PACE, you know, it would be a major opportunity to do public education out of churches around how to lower emissions.
Yep.
You know,
Great. No, yeah, absolutely. Solar and electrification of heating, hot water heating and all that. It's that's exactly that, produce more, electrify everything and greenify the whole thing.
yeah.
I noticed that Alan Linoff answered your question, Jim, about using Energy Sage for solar. He said he used it for his home solar and was very pleased with how it worked. So we're getting on to past 8:15, and I'm thinking we may need to wrap this up at this point. Does someone have a burning question that they would like to ask that hasn't been raised already? Well, if not, or seeing none, I'll pass it back to Cindy Davidson for concluding remarks. And thank you all very much for coming.
Thank you, Jim. And thank you, Bill. And thank you to everyone who asked questions. I wanted to just close out, we've done those things, and let you know that we do have some resources on our website that might be of interest to you. If you use the drop-down menu called ACT, there are sections with entries under Everyday Environmental Stewardship and Congregation Success Stories. You'll find there a technical brief on air source heat pumps for heating and cooling that's been updated, I believe, in 2021. And also, we were just talking about linking together heat pumps and solar panels and energy efficiencies in the envelopes. There's a very nice success story from South Congregational Church in Amherst. I will be sending links to these documents in the post-event email that you'll be getting, hopefully tomorrow. We want to thank everybody and let you know how you can contact anybody who's been part of this presentation this evening. Our presenters are sharing their email contacts as our Mass IPO people. And again, I will include this in the email that you'll receive afterwards. And thank you. Thank you to the speakers and facilitators, to our co-sponsor, JCAN, the Jewish Climate Action Network of Massachusetts, which helped us publicize the event, to our environmental stewardship assessment team that you've met, Bill and Jim, to all the congregations and individual donors who are making our work possible, and to all of you for all that you are doing in your own communities and lives to work for a livable climate. Thank you for being here. We look forward to seeing you again soon. And I will hang on a little while, a few more minutes, if anyone wants to share anything in the chat on their way out. You.